single-seat fighter pilot is a fairly unique thing to be.
The traits that make a good fighter pilot are absolutely universal. No matter what plane he's flying, he's got to be able to multitask, be very effective at making good decisions, obviously be athletic and in good physical condition.
The ability to field the aircraft is certainly an important capability for you to be able to maximize the maneuvering of your aircraft. No doubt about that.
They've done everything they can do prior to the mission to try to eliminate as many of the unknowns as they possibly can. There's always risk, but there's always an understanding of what the risk is versus the reward. What we're trying to do is we're trying to challenge everybody and take them right to the peak of their proficiency. It's the young guys that are flying it and they say, wow, this was supposed to do this, but I can take it and I can do a whole new thing with it.
First time you take the F-22 into a large force employment exercise like Red Flag, that's when you really start to appreciate what this leap in technology gives you.
We get to give them the best training in the world. We get to put them through those bloodless battles, and then they'll be so much better for it when they actually have to go execute the mission.
The challenge for us is to know that there are threats out there that can present a serious challenge to our air superiority, and that we always need to be on the cutting edge.
We would like to think that every graduate of the United States Air Force Test Pilot School has the potential to be a senior leader in our Air Force. It is difficult, but if they weren't able to hack it, they probably wouldn't be here.
If we can get those talented people into the test world, now they can be the smart people who are testing those weapon systems, make them better to the warfighter as fast as we can so that they can use them in the combat environment. And that's what I'm excited about.
It's one thing to do science in a lab. It's another to do science inverted at 450 knots, pulling a few Gs. I mean, that's just a blast.
Now we're in the 21st century. The limit is out there. You know, how much are we willing to press that limit?
Red Flag offers us that rare opportunity to fly very close to what we would actually have to do were we called into combat operations.
When I went through pilot training, there was one thing I wanted to be, and that was to be an F-15C pilot. A single-seat fighter pilot is a fairly unique thing to be. Very task saturating because you not only have to worry about maintaining visually your flight lead, but you're working your radar, listening to your radar warning receiver to make sure people aren't targeting you. The United States Air Force is maintaining air superiority. It's not just because of the aircraft like the F-15, it's also because of the superior training of our pilots. And Red Flag is a key component of that.
The good news is that we have full air superiority in Iraq and Afghanistan. That might not be true on the first night of any combat operation that we would see in the future. And so we're taking our young people right now who are very used to operations in a place where they have air superiority and putting them in a situation where they don't, where they actually have to go get air superiority. And that is a very different animal for them to try to figure out.
Red Flag for 35 years has been providing the most realistic combat training that we can present our forces. What's changed over the 35 years is the threat continues to get better. In the current fights, they are using very critical skills with friendly lives and national interests on the line, but they're not always using every system. They're not contested by air threats and surface threats, cyber threats. Here, we'll let them get together with their international allies, their joint partners, and they have to bring all those capabilities into one cohesive plan to achieve the objectives, to fight their way through a very tough adversary. What we want to replicate is being outnumbered. We think one-on-one will beat anyone, anywhere. But if it's one-on-3 or one-on-4, do we have the capability? Do our missiles work? Do our tactics work?
The history of red flag evolves from a study that was done over World War II. And what that study told us was that if you could survive your first 10 flights as a pilot, you had a very good chance of surviving the rest of the war. So what we do at Red Flag is we try to simulate as close as we can those first 10 flights in a very hot war. We take off and we go do this realistic training, and it involves quite a bit of air-to-air activity. And one of the great things that we're able to do is we're able to simulate the surface-to-air threats that can shoot at us in the real world.
The idea of Red Flag is to train like you fight. So you get the opportunity to experience what combat is like without the actual threat of loss. You also get the chance to integrate with ground assets, get shot at by simulated surface-to-air missiles. The beauty of Red Flag is you have all sorts of different players, anywhere from F-16s to F-15s, tankers, AWACS, all those different types of aircraft, and you have one mission, and that is to deliver bombs on target on time.
Well, with the B-52, since we have a lot of gas, we usually take off before everybody and hold for 30 minutes or so. It's an orchestration is what it is. We go out and hold and wait for all our fighter assets and all of our whole package to check in, and then they'll clear out some airspace for us and clear out some ground threats, and then we'll push in and hit some targets. There's quite a bit of competition here. You imagine getting all these Type A personalities in one room and then tell them out there and go and go fight. You can come and get experience from other weapon systems, find out what they can do for you, what you can do for them. And the B-52 might not be quite as nimble, but you just have to plan ahead and give some time for reaction.
Our adversary tactics group are the experts. They know, teach, and replicate every system and every threat region on the globe. Our aggressors with the F-15s and F-16s do the best they can.
It's a pretty selective process to become an aggressor. Almost all of our new guys that we get in have at least one fighter tour, mostly two. Most of them are instructor pilots when they show up here. In the aggressors, we have a mantra of know, teach, and replicate the threat. And so a big part of that is knowing what the threat aircraft do out there and then teaching that to the combat air forces. But when we replicate a threat out there, we don't try to replicate the country. All we're doing is we're replicating a capability that a threat aircraft might present. We definitely tailor it to obviously the current conflicts that we're in, but we also try to look forward to what future conflicts we might have and kind of give a worst case scenario so that hopefully anything that they see here hopefully will be worse than anything they see in real life.
We typically will go up against a pretty significant red force, and that would include aircraft in the 10s to 20s, as well as surface-to-air threats.
The adversaries are experts on their weapon systems and in simulating bad guy threats. The adversary tactics are very unpredictable, and that's the challenge of it, is you have to react and make sure you overcome and adapt to whatever presentation they give you.
As far as the blue players, the good guys, we usually work together and make sure we get things done before we let pride get in the way. The bad guys we call red air, and we go out and fight against them, and nobody wants to make a mistake, and nobody wants to be the guy that caused the package to get shot down.
Everyone remembers when they were killed on the Nellis ranges, and that is intentional. We make it very difficult that happens to them, that they're put in a position where they're threatened by all the domains in training, so that when it happens in combat, they know what to do. They see things going bad quicker. And so what we're trying to do is build their confidence in a more complex operation.
Any sort of combat engagement, at least the ones that I've been on, looked remarkably similar to a red flag package. I know for me, going to my first red flag and seeing stealth up close, talking to them on the radio, integrating them into our strike packages paid huge dividends for us later on in Allied force and operations over Kosovo. The great part about being in red flag is that you've been there before, you've seen it, your nerves are a little bit calmer. You recognize when things are going right and when things are going wrong, and you can react appropriately.
The challenge for us is to know that there are threats out there that can present a serious challenge to our air superiority, and that we always need to be on the cutting edge of pushing forward, making sure that we're still staying prepared.
You just came from fighting the fight. You're now going to fight the future.
Red Flag is a gift that was given to us by those who came before us. They gave us the gift of realistic training.
Don't get too high and don't get too low. When you get too low, if they shoot at him and you're lower, they'll probably hit you.
I did a combat tour at Udorn in 1969 to 1970. I was in the triple nickel. We flew F-4Ds. We were all young. We were all aggressive. We were all trying to do the best we could do with what we had. There was a tremendous belief when we left Vietnam that there were a whole bunch of things that we could have done better. Some of those changes in our culture and the way we did things actually happened during the war. And so when we came out, it was just a logical extension to keep going with those.
Yeah, I'm right over the target right now. I've got a 17 right in front of him.
Some of the things that we had been taught in our training when we went to combat with them did not work against what we called dissimilar adversaries. You know, what you would do against another F-4 attacking you wasn't necessarily the right thing to do if a very small, smokeless, hard to see, highly maneuverable MiG attacked you.
Roger, I'm going to break off right. I see him loud and clear. Detroit, we got things right under us, right under us.
You really have to have dissimilar training and dissimilar adversaries. And we brought that lesson out of the war. Well, one of the ways that we teach them how to do it is Red Flag. They wanted realism. They wanted Red Flag to be like it was over Hanoi. And they wanted it to be that way, even to the extent of getting real-time feedback, where they would say, Blue 3, you're dead. And he would have to, that airplane would have to leave the fight. The challenge for the F-15, F-16 guys who are in a mature weapons system, I think the challenge for them is being able to work with mixed forces. In the 5th generation airplane like the F-22, the challenge for them is getting enough flying hours because it's a new system.
First time you take the F-22 into a large force employment exercise like Red Flag, first time you get this aircraft in there, you almost don't believe it's real until all of a sudden, sure enough, you roll in on somebody that have absolutely no clue that you're there.
Having previously flown an F-15C, we had to take multiple sensors on that aircraft, put them together, and create a picture within our own mind. This aircraft actually takes those sensors, puts it together, and it gives us one integrated picture that we're able to make decisions off of.
That computer technology frees me up a little bit to make better decisions, faster decisions on the battle space, bring the technology and bring the weapons and capability of this aircraft to bear much, much sooner and more effectively.
What we're trying to do is we're trying to challenge everybody and take them to right to the peak of their proficiency. But until you put the airplane in their hands and they go fly it, you really don't know how far it can go. You know the basic it can do, but the young guys are the ones that take it into horizons never before envisioned.
I think what they really need to have is curiosity and a love of aviation. The relationships that you cultivate at test battle school, you will have for the rest of your career. It is difficult, but if they weren't able to hack it, they probably wouldn't be here.
It's going to give you a dynamic, so you're actually going to get more of the pitch damping.
You just came from fighting the fight. You're now going to fight the future. You are going to be involved in ensuring that some kid who you do not know, some kid who's going through junior high right now, that he or she 15 years from now can have better weapon systems than what you had, because the stakes will continue to be high. You're doing higher level math since day one, and you're doing very challenging flying in airplanes that you may not have previously been familiar with from day one.
This program is like no other in that you learn more about airplanes than anybody ever knew was possible. You get to fly all kinds of different airplanes. So it exposes us to so many different types, shapes, sizes of aircraft so that when we do get out to the test world, we're prepared for whatever might come our way. My last assignment was at Kadena Air Base in Japan. I was flying F-15Cs out there. You know, I loved the combat type environment, but I also recognized while I was there that there is a lot more to getting weapon systems ready for that kind of environment than I ever knew possible.
Now at Rosman, I'm there at 23.7. There's one at 23.2, quite a bit faster this time too.
There were talented people behind the scenes in the F-15 who worked on all those systems before I ever got it as a warfighter, and I wanted to be one of those people.
Rolling 3. 1, 2, 3, 1, 2.
For us who are engineering minded, it's a great place to be because we get to apply the engineering side of it, or if you will, the math, physics side, whatever your degree happens to be, to the flying aspect of it, and it melds those really well.
They will be able to answer a variety of questions. They will be dealing from everything from advanced electronically scanned array radars. We talk about electronic warfare. We deal a lot with airborne networks. We deal a lot with systems integration, weapon delivery, weapon guidance, navigation and control.
The flying side has been awesome. I think I've flown 5 different airplanes in 1 week, and that's challenging in itself. You go through pilot training a whole year, and now you're back in it again, but now it's 10 times harder than what pilot training was. Not only do you have the flying, which is the same tempo, but now you got all the reports and the academics that go along with it. Academically, it was exhausting to go back to those college days of doing all the nerd stuff. Dusting off those old books and learning how to get back into the academic side of the house was extremely challenging. Deployment to Balad Air Base, Iraq. It was a 4.5-month tour there for the 55th Fighter Squadron in support of Operation Iraqi Freedom. F-16s daily there in Iraq. We'd fly a mission a day there for, I ended up logging about 55 sorties while I was there. Doing the mission day to day, seeing how it impacts the ground troops. So it's much more challenging what I thought it would be, but pilot training and the previous 6 or so years of my life has really prepared me for this adventure here at Test Pilot School.
You're working on projects that, as soon as you complete it, the warfighters, the guys operating the aircraft are going to see that change. And like I said, that kind of immediacy, that kind of contact directly with the operator, with the warfighter, was something that really drew me to the test world out of R&D. I was working at the Air Force Research Lab at Kirtland Air Force Base. It was an interesting place to be, a very diverse group, a lot of civilians, a lot of senior scientists. Test Pilot School is great because it combines that cerebral approach that a lot of us scientists and engineers are used to with the visceral thrill of flying. And it's been exciting. I mean, it's one thing to do science in a lab. It's another to do science inverted at 450 knots, pulling a few Gs. I mean, that's just a blast.
The impact we have on the combatants, the capabilities, the weapon systems, even tactics to a certain degree is astounding. They are trained to look into the future and realize that this may be an issue 10 years hence. We can identify issues, challenges much earlier on in the developmental cycle of a program than anybody else out there.
They're still, the best and the brightest, as they say. And they certainly have been, for the past, now we're going 50 years. And the applicants to the school then were absolutely the best and the brightest. Coming out of World War II, the Flight Test Division had a lot of new combat pilots they brought on board. Many of them were fighter aces. Many of them great in combat because they could respond and react and kind of improvise. But flight testing requires precision flying. It requires the pilot to fly a mission exactly as it has been plotted by the engineers. Many of whom had been aces, found this kind of boring. And hence they found they didn't have the discipline and the patience for a flight test job. They looked for people who were detail-oriented, were meticulous, willing to complete meticulous planning and preparation. They looked for people with, if you will, a high technical aptitude, at least, that they were oriented towards machines. Maybe they couldn't understand them intellectually, but they had a great feel. Chuck Yeager was such a great example of that.
Men like Yeager. In an age fascinated by higher, faster, farther, these men won worldwide acclaim.
In the 50s, you'd have a new airframe, a new fighter almost every year. We had a lot of accidents. You know, Yeager has told me many times, General Yeager, well, heck, back in those days, we just viewed it as part of the cost of doing business. But today, with the high cost of these airplanes and systems, bad news is bad news, and it's not good for any program. Now, this adds a level of risk and a requirement for a degree of courage that the pilots of the 50s didn't appreciate, didn't feel. I think that the test pilots then, as the test pilots today, see their primary role as ensuring that their peers out there in the operational Air Force go into harm's way with the absolute best and safest, most effective combat systems in the world.
I want to get my bros in the field the best tools that I can so that they can do the mission better.
You got to take it step by step, not rush any steps, not shortchange any of the tests out there, so that you do present that 100% F-35 ready to go to the warfighter.
One of the things that we constantly try to ensure that we're doing at test pilot school is having a curriculum that is relevant to the combatant and the needs of the combatants 10, 15 years from now. Risk mitigation and ensuring that we get the best combat capability for our airmen. That's really the bottom line. We're incorporating remotely piloted aircraft to our curriculum. It's actually going to be essentially the same as our weapons systems officer curriculum right now. The typical RPA student that we're seeing applying to the Air Force Test Pilot School is a rated officer that transitioned pilot or WISO who transitioned to RPAs. They have a strong background in their manned weapon system. For the most part, we have the same type of individual as for the traditional courses. They are passionate about aviation, they are intellectually curious, and they have a very strong background in math, science, and engineering. And that's exactly the person we want. We are keeping our pilots and all our air crews who are doing developmental tests in RPAs current in some other platform where they can get some current, recent operational exposure.
I flew a KC-135 yesterday, and talking to our student peer that had flown the KC-135, I have an utmost appreciation for the handling qualities that he was compensating for. Likewise, he's learned about fighter aviation.
Ultimately, our students are going to go through the program and have the same exact background as their peers, so they can also bring that point of view from other weapon systems to the development of these remotely piloted aircraft.
I want to be as efficient and effective as possible at getting the operator what it is that they've requested with regards to capability. I think I've done my job if at the other side of this school the operator gets a better technology than they expected to get years ago.
We focus on keeping our graduates sharp by providing them opportunity to test and be involved in a variety of tests.
I think it's going to be big. It's huge. It's a whole totally different ballgame what we're dealing with the JSF. You know, we're going leaps and bounds with what the F-16 provides, you know, and the F-15 provides. Yeah, with a fighter background, I'd love to continue in the fighters. JSF, of course, who doesn't want to go into that? That's the test right now. That's the program to be in as far as getting that impact to the warfighter. You got to take it step by step, not rush any steps, not shortchange any of the tests out there, so that you do present that 100% F-35 ready to go to the warfighter.
There was always something in my heart for the F-15, so I'd love to go and do F-15 testing. But I'd also love to get into some of the 5th generation fighters, the F-22 or F-35. I think those are great platforms, and I'm looking forward to working with them and working with the people who built them and those who are already flying them. I think that there are challenges with that, and that the pilot is not directly linked with your sensor, and so there's all kinds of computers in between and the interfaces, and making sure that those are correct and trying to figure out, you know, if something is wrong, what is it? Is it the sensor? Is it the computer in between? Is it the operator? And there's all kinds of things.
The transition from that 4th generation fighter fleet like the F-15, F-16 to the F-22, the 5th generation, and the F-35 is really a huge leap in technology.
In the F-22, flying against multiple other aircraft, especially in a large force environment. It's amazing that the core of our aircraft, the stealth, the speed, the agility, that really does work, and it's proven time and time again, especially in the larger force exercises with multiple players. It gives us an increased capability to help fourth generation fighters that we may be integrating with, that we may be fighting with, especially joint and coalition partners.
In my opinion, the biggest difference in the aircraft that we fly today and say 10, 15 years ago is we have the ability to share our combat data with each other from airplane to airplane. Teamwork is key. And if you can share that data without actually having to talk on the radio, we can come together as a team in a way that's much more effective than we ever were able to when all we had connecting us was the radios.
You now have more sophisticated avionics, so that allows you to do more things in the battlefield. It allows you to control more assets. Back in World War II, it's probably just you and your wingman, or maybe you worked with a small group. But now you're responsible, if you're the mission commander, for many different aircraft, 40, 50, sometimes 60 aircraft.
The basic mindset hasn't changed since the beginning of flying combat aviation. And our young pilots are no different than we were. The difference is they're so much smarter. They grew up in a technical world, whereas we grew up in an analog age. So they are so much better at being able to process data and manipulate the scopes that are in their cockpits than us dinosaurs were ever able to do.
As a mission commander, you can lead a 40, 50 ship package out there every day, every night. Building confidence, it really helps you on further in your career. So hopefully the combat experience that I've had in the past, being able to get to the warfighter, that 100% mission capable, mission ready aircraft is what's very important.